Okay, so today I told you guys that we're going to get into our most difficult section of our unit of the year probably, and that's called factoring. Again, today's unit or this note topic, I'm going to try to make it brief and quick. It's not too terribly difficult, but we're not going to spend a whole lot of time on this. So let's just go ahead and jump right in. First of all, we're talking about monomials and factoring, or monomial factoring, and what we want to look at here is what factors mean. We talked in class a little bit today about factors are two numbers that you multiply together in order to get a product. So on the first example here, when it's asking us to find the prime factors of the following numbers, like the prime factors of 12, what it's wanting to do is a prime number is a number that can no longer be multiplied by anything but itself and 1. So we want to get as far down as possible. So we want to factor this out, create a factor tree, if you will. Some of you guys might remember this when we start seeing it. So let's go ahead and start creating that factor tree. Well, what we're looking at is if we look at 12, factors of 12, you might think to yourself, well, 6 times 2. Well, can 6 be broken down any more? Yeah, 6 can be broken down to 3 times 2. Can 2 be broken down anymore? No. So 2 just comes down as well. So if you look there, you have 3 times 2 times 2, okay, which equals 12. Our prime factors then are going to be these right here. Okay, the next one. And again, I can't factor 3 any further. I can't factor 2 any further. I can't factor 2 and again any further. But those still multiply 3 times 2 times 2. Now you might be asking yourself, well, or you might be telling yourself, well, what if I didn't do 6 and 2? What if I started with 12 and then I went to 3 and 4? I'll give myself a little bit more room here. What if I started with 12 and I went 3 and 4? Well, here's 3, here's 4. 3 times 4 is 12. Can I factor 3 anymore? No, so 3 is going to come down. Can I factor 4 anymore? Yeah, it's going to become 2 and 2. So 3 times 2 times 2. Notice, it's the same factors that we already have. It didn't change anything. So in any case, when you go down to your prime factors are always going to be the same no matter which avenue or which street you take. And again, factoring a number, a monomial or a constant in this case, you want to factor all the way down until you can't factor anymore. Okay, let's look at the next one. 210. Well, if I think right away about 210, I think of 21 and 10. Can I break 21 down further? Yeah, I have 3 times 7. Can I break 10 down any further? Yeah, 5 times 2. So 3 times 7 times 5 times 2. Can I break 3, 5, 7, or 2 down any further? No, I cannot. So those are my factors of 210. Those are my prime factors of 210. If I multiply 3 times 7 times 5 times 2, I'm going to get 210. Okay. At any time, if you have any questions over this, please make sure that you write the question down so you can bring it to me in tutoring in the morning. All right, let's go ahead and look at the next one. The next one says factor the monomials. This one's a little more complicated. Okay, so when I factor the monomials, it's not that it's complicated. It's just I have variables in there. I have 15a cubed and b squared. So if I do that and I want to factor this down, I'm still going to do the same thing with my 15. Okay, what are factors of 15? That I could break it down. Well, it's 3 times 2. 3 times 5. Okay, can I break down 3 and 5 anymore? No. So then you have 3 times 5 times Now a cubed, how many a's do I have? I have 3. So times a, times a, times a. How many b's do I have? I have 2. Times b, times b. Can I go any further than that? No. So there are my factors of 15a cubed b squared. Okay? Let's look at the negative 45, xy squared. Okay? First thing I want to do is break down my negative 45. Negative 45 is negative 9 and 5. Well, negative 9 can be broken down to negative 3 and 3. And then, of course, 5 still comes down. But negative 3 can also be broken down. Okay? We want to take that negative 1 out. So then you have negative 1 and 3 times 5. Now we can't forget about the x. How many x's do I have? I have 1x, so that comes down. And then how many y's? I have 2 y's. Times y times y. So there are my prime factors of negative 45xy squared. Okay? Let's look at one more example. Let's break down 7 r squared s to the 5th and t. Okay, does 7 break down any further? Well, I could do 1 and 7, but 1 is almost understood as always a factor. So 7 just comes down. And then I have how many r's? Times r, there's 2. How many s's? Times s, times s, times s, times s, times s. And how many t's? Just 1 t, times t. So really all I had to do is break down each component there, and that is my prime factors. Okay, and again, we're not going to do this one. I know it looks like a lot of work and a lot of expanding and redundancy, but we're not going to do a whole lot of those in our class. I mean, that's just kind of a foundation. Like I told you in class A, it's more of a foundation than anything else. Okay? All right? Let's continue on in our notes. Okay, the next part says, the blank, okay, that blank should be greatest, well, that's not going to work, greatest common factor. Or we call this the GCF. The greatest common factor, or GCF, of 2 or more integers is the product of the factors, is what this line is, common to the integers. Okay? So what that means is I'm going to take out what those two products, those two factors share, and then I'll multiply them together. So you'll see a lot of that as we continue to move forward. All right? So let's look at our next example. It says find the GCF of 15 and 35. Okay, so what do they have in common? So I want to break these down again, like we've already done in the first one. Let's see. So I'm going to show you the first one the long way, and then we're going to start getting into more mental math, because ideally, by the end of this unit, you want to be able to do this mentally. So let's do the first one. So the first one has, what do they have in common, 15? Well, the factors of 15 are 3 and 5. We know that. Factors of 35 are 5 and 7. So now we have to figure out, what do they have in common? Okay, well, they both have a 5 in common. So the GCF then would be the greatest common meaning what they have the same, the greatest common factor is 5. Again, we want to kind of do this mentally. So I want to go through B, and I want to do this mentally so that we kind of can practice that. So what we do when we do it mentally is we say, okay, let's find the factors of 12, the highest factors of 12. Start with the highest factors of the lowest number, okay? So here's my lowest number right there. I'm going to start with the highest factor of my lowest number and figure out, does it go into all the others? So the highest factor of 12 would be 12, because 12 times 1 is 12. So then you have to say, okay, and all this is going to be done in your head, really, too. So does 12 go into 42? Well, 12 times 3 is 36. 12 times 4 is 48. So 12 does not go into 42 evenly. So that means 12 is not a greatest common factor. They don't share that. 12 does not go into 42 evenly. So then go down to my next lowest factor of 12. Well, my next lowest factor of 12, it's not 11, 10, 9, 8, 7. 6 would be my next one, right? So let's say 6. Does 6 go into 12? Of course, 6 times 2. Does 6 go into 42? Yeah, 6 times 7 is 42. Does 6 go into 96? Yeah, 6 times 16 is 96. So they all have a 6 in common. So it works here, it works here, and it works here. Since 6 is the highest of my low, that works. My greatest common factor is equal to 6. This is going to save you a lot of trouble. You don't want to do the high. You don't want to start with your highest because, like, for example, 96 has a factor of 16, but 16 doesn't go into 12. There's no way there's anything that multiplies by 16 that goes into 12, so that won't work. That's why you start with 12, your lowest number, and you look for the highest factor that will work on all three of them. So that's where we got 6 from. Okay, let's go ahead and look at the next example. Okay, on the next one it says find the GCF of each of the set of monomials. Okay? So here I'm doing the same thing as I did before. Okay, so what is the greatest common factor between 27 and 15? Again, I'm going to start with 15. Okay? So my factors of 15 are 15 and 1. That's the first one, right? Does 15 go into 27? No, it does not. So that doesn't work. So my next lowest would be 5. Okay? So then I'd go down to 5. Does 5 go into 27? No, it does not. So then my next one would be 3. Okay, does 3 go into 27? It does. So far, my GCF is equal to 3. So now my big numbers are taken care of. So now we have to look at our variables. This is a little bit different than looking at a number. When I look at my variables and I see if they have a common factor, what I'm going to do is, do they both have the same letter? Okay? So do both of these have an A? Yes, there's an A there and there's an A there. They both have an A. Now, the greatest common factor, if they both have an A, or both have the same letter, is the lowest variable with the lowest exponent. So in this case, that would be the A right here. Okay? Because that A has an exponent of 1, this one has an exponent of 2. So your greatest common factor is just going to simply be A. So now I'm done with A. Let's look at B. Do they have B in common? Yes, they do. They both have a B. What is the lowest B value? Well, there's a B squared and there's a B to the first power. So your B to the first power is going to be your greatest common factor. It's the lowest. Because what that means is they both share B's and they both can give up a B. Okay? But the 27 can only give up one B, whereas the 15 can give up two B's. Well, they can only both equally give up one each. Okay? And then finally, do they both share a C value? No, only this one has a C. Only the 15ABC has a C. There is no C here, so C is not part of your greatest common factor. So your solution then is going to be the 3AB. So your greatest common factor there is 3AB. They all share 3 in common. They all are multiples of 3. They all have A in common. They all have a B in common. C is not in there because the other one does not have a C. So let's look at another example. Same thing, same process here. We start with our numbers, negative 39 and negative 26. What do they have in common? What's the greatest factor of negative 26? Right now it's negative 26. Does negative 26 go into negative 39? No, of course not. It doesn't work. So go down. What's another common factor? Okay, well, negative 13, that's a big one. Okay, negative 13 times 2, right? Well, negative 13, does it go into negative 39? Yes, it does. It goes in there 3 times. So since negative 13 works in both, our greatest common factor is going to start off as negative 13. It's negative because they're both negative, so pay close attention to that. If you have 2 negatives, you can pull that negative out. So our numbers are done. Again, do they both have an x in common? Yes, they do. What is the lowest x? Well, here's an x squared. Here's an x. So the lowest x is x, so bring it down. And then finally, they have y's in common. Yeah, y cubed and y to the 4th. They both have 1 in common. Yes, they do. What's the lowest one? Y to the 3rd power here is the lowest. Okay? So my greatest common factor is negative 13 x y cubed. Because again, if you go back and you evaluate this, you're going to see they all have a 13. They all have each one of those numbers has a negative 13. Each one of them has at least 1 x, and each one of them has at least 3 y's. This one over here, that one has 3 y's, but it doesn't have a 4th one. So the greatest common factor is only 3. All right, again, please write down any questions you may have and bring it to me in the morning. All right, here's our last example. We'll go ahead and clear this and move it up. Okay, this one says the sides of a triangle are 12wz squared okay, 8wz and 16w squared z. It says find the greatest common factor of the 3 sides. Okay, so all I'm going to do is I'm going to take these down. I'm going to rewrite them. 12wz squared, 8wz, and 16w squared z. All right, so again, working on our mental math. Start with the lowest number, and start to break it down. So the highest factor of 8 is 8. Does 8 go into 12? No, we know 8 doesn't go into 12, so 8 doesn't work. Our next highest factor would be 4. Does 4 go into 12? Yes, it does. Okay. Does 4 go into 16? Yes, it does. So 4 is our number. So now we just start looking, and we can go from any one, start anywhere, start looking at the variables. So W, do they all share a W in common? There's 1 here, there's 1 here, and there's 2 there. But our lowest amount of W's is 1. So W is going to be our greatest W value that they share. And then now Z. Do they all have a Z's in common? Well, there's Z squared there, there's 2 there. There's 1 there and 1 there. What's the lowest Z that they have that they could possibly share? Well, that's just 1 Z. So the z's are taken care of there, and there's nothing else to look at to factor. So our greatest common factor, they all have a 4 in them. 4 times 3 is 12, 4 times 2 is 8, 4 times 4 is 16. They all have a w in them. There's one w, and there's 2. And they all have a z in them. There's 2 z's, 1 z, and 1 z. I can't put 2. This doesn't work because there's not 2 z's here or here. That's why we only put 1 there. So keep that in mind. Okay, that's important that you know that. So here's our answer. 4WZ. And that's it. That's all you need to know for tomorrow's activity. Make sure you watch the video. Hopefully you got notes. Bring those notes with you to class tomorrow. And we'll knock out this activity, and then we'll get into the big time stuff on Tuesday night and Thursday. Tuesday night and Wednesday night. All right, have a good night.